answering the worksheet for the electrolysis. Okay, now we will start with the first one, molten salts. Molten salts, that means that the salt we heated it and now it's liquid. So it's salt in the liquid state. While having the salt in the liquid state, so the only ions that we have are the ions of the salt. We don't have any extra ions. For example, ZnCl2, the first salt, ZnCl2. So we have the Zn plus 2 and the Cl minus. We have two types of ions, Zn plus 2 and Cl minus. So the reaction at the cathode. At the cathode, the cation, which is the positive ion, so cation اللي هو positive ion, will go to the cathode and be reduced. So Zn plus 2, it will accept 2 electrons and reduced to Zn. Now at the anode, we will have the anion, which is the negative ion. The negative ion here is the Cl negative. Cl negative, it will be oxidized by losing 2 electrons and giving Cl2. Cl2 gas, 2 Cl minus will give us Cl2 gas and 2 electrons. Now the product at the cathode, the product is the Zn, the zinc. Product at the anode, as you can see here, is the Cl2, the chlorine gas. Left over, okay, the leftover. Do we have any ions that did not react? In this example, because it's molten salt, and as we said, the molten salts have only the ions of the salt, so there is no leftover. For the second one, PbBr2. Also, we have two types of ions. We have the Pb plus 2 and the Br minus. Pb plus 2 and Br minus. Okay, at the cathode we will have the positive ion, so Pb plus 2, it will accept electrons and the product will be Pb, lead. At the anode, we will have the negative ion. Okay, also always notice that we start with the ion. What I mean is, the reactant here is the ion. The reactant here is the ion. The reactant here is the ion, and the reactant here is the ion. So the ions are the reactants. And during the reaction, they get discharged. So we have an ion here, the positive ion. It accepted electrons and it is now without charge, so it is discharged. The same for the Pb plus 2. It was positive, it accepted 2 electrons and it got discharged. For the Cl negative, it lost electrons and it got discharged, Cl2. Here the Br minus, the same, it lost electrons and it got discharged. Now, the product at the cathode in this is the Pb with no charge. And the product at the anode is the Br2, also with no charge. And there is no leftover. So always in molten salts, we only have the positive ion of the salt and the negative ion of the salt, and we don't have any leftover. Okay, number 2 is the electrolysis of concentrated salt solutions. So we have solutions, not molten, solutions. Salt, they are concentrated. And since we are talking about solutions, so we have to mention that there is water. So in addition to the ions of the salt, we have also H plus and OH minus. We have 2 extra ions. So for each one of these, I will write the ions and I will write in addition to them the ions of water, the H plus and the OH minus. NaCl, so we have the Na plus and the Cl minus. We also have the H plus and the OH minus. Now, at the cathode, reaction at the cathode, the cations will go to the cathode, so we have the Na plus and the H minus. As we said before, always the less reactive ion is the ion that will be discharged at the cathode. So H plus is the ion that will be discharged at the cathode. So I will take H plus here. It will accept electrons and it will give hydrogen gas. So the product at the cathode is H2, the hydrogen gas. Reaction at the anode. At the anode, we have the Cl minus and the OH minus, the 2 anions, Cl minus and OH minus. We always say that if we have a halide, the halide will be discharged at the anode. So the halide here, the Cl minus. So the product at the anode is the Cl2. As you see, these are the products. We are talking about the products. Okay, now the leftover. Which ions are left? The Na plus and the OH minus. So you can write the leftover as Na plus and OH minus, and they also will react to give me NaOH. So the leftover is NaOH. Sometimes they ask about the ions from the leftover and sometimes about the product, the leftover, sorry. Well, I mean the compound. Number 2, MgBr2. We have the Mg 2 plus, Br minus, H plus, OH minus. At the cathode, hydrogen and magnesium. Hydrogen will be reduced. So the product is hydrogen gas. At the anode, we have the Br minus and the OH minus. Since Br minus is a halide from group 7, so it is the Br minus that will be discharged. So the product here is Br2. Okay, the leftover, we have two ions left that did not react, the Mg and the OH, Mg plus 2 and OH negative 1. So we have here Mg plus 2 and OH negative. Together they will give MgOH by 2. Now the next is the concentrated acid solutions. So acidic solutions, concentrated. Since they are solutions, so also I have water. So for each one of these, when I write the ions, I will write the ions of water as well. For the first one, H plus and SO4 negative 2. The ions of water are also H plus and OH negative. At the cathode, we also, for both of them, we have the H plus, so the H will be reacted and reduced to give us the hydrogen gas. Now at the anode, we have SO4 minus 2 and we have OH minus. Since there is no halide, I will take the hydroxide. So as you know, no halide, then the hydroxide. You know the hydroxide's equation? Okay, now the product at the anode is O2. Why don't I choose the H2O? Because it will stay in the container H2O. So as we just adding more water, it's water, so it is in the container. So H2 and O2 are the products. The leftover, the H plus and the SO4 minus 2, which will give the H2SO4. The second one, for the HCl I have H plus, Cl minus, and from the water I have H plus and OH minus. At the cathode, H plus will react okay, I will omit any of them. At the anode, since I have the Cl minus, the halide, then the halide will react so the products are H2 and Cl2. The leftover are the H plus and OH minus. Will give me H2O. Now, concentrated base solutions. So for each of them we have bases and we have concentrated base solutions. And as we said before, since they are solutions, so they have the ions of OH plus and OH minus, the ions of water. KOH, K plus, OH minus, and water, H plus, OH minus. At the cathode, we have the H plus, sorry, the K plus and the H plus. The less reactive is the H plus, so H plus will be reduced to give H2 gas, the hydrogen gas. At the anode, both are the OH minus, so the OH minus will be oxidized to give H2O plus O2 plus 4 electrons. So the product at the anode is O2. The leftover, the K plus and the OH minus that did not react, any ion that did not react is left over. So K plus and OH minus, which will react to give KOH. I think this is confusing. Okay, the second one, MgOH2. Also we have Mg plus 2, OH minus, and H plus, OH minus. Again, at the cathode, the less reactive is the hydrogen. At the anode, we only have one choice, which is the OH minus. The products will be H2 and O2. The leftover as the Mg and the OH minus, so Mg plus 2, OH minus, which will give the MgOH2. This is the leftover from this reaction. Now, the last part is about diluted solutions, salt solutions or acid solution or alkaline solutions. Okay, when we have a diluted solution, the most important thing when we talk about diluted solutions, that no enough ions of the electrolyte to give a noticeable amount of products. It will seem that we only have the ions of water, the H plus and the OH minus. Okay, let's start. NaCl. Okay, we have Na plus and Cl minus, and also we have H plus and OH minus. Okay. In concentrated solutions, when we were talking about Na plus and Cl minus, okay, we choose the H plus here because it's the less reactive ion or the less reactive element, so we choose it here. And at the cathode, at the anode, we choose the Cl minus. We choose the Cl minus because it is a halide. Okay, now talking about diluted solutions, we have to notice that the amounts of Na plus and Cl minus are negligible. We can just ignore them. Ignore the presence of Na plus and Cl minus. Okay, The Cl minus will react, but we can't notice the reaction of of Cl minus. We will only note the reaction of OH minus at the anode. So at the cathode, we will have the H plus at the anode. So the product at the cathode is the H2. At the anode, as I said before, we have the OH minus. So the product at the anode is O2. And the leftover, okay, I just omit these. I mean that leftover are Na and Cl. Okay, I will be repeating the same equations for both the cathode and the anode, and the same products for the cathode and the anode, and I will be repeating the same electrolyte in each one as a leftover. So just like if I don't have any electrolytes. So for HCl, the H plus and the Cl minus, we just ignore them. So the H plus from water and the OH minus from water as well. And the leftover are the H plus and the Cl minus, which will give the HCl. KOH, same idea. H plus from water. So the product at the cathode is the H2. OH also minus from water. So the product is O2. The leftover is the K plus OH minus, which is the KOH. The last one, at the cathode, the H plus from